All right, so sorry about that, but we're back. So operations on rational and irrational numbers, okay? So what we want to do is we want to calculate the following numerical expressions, classify the answer as rational or irrational, all right? So write your answer as an integer or as a fraction. So in this case, we have 1/2 plus 2/3, okay? 1/2 plus 2/3. So when we calculate this, we got to make sure that first, before we add fractions, we got to make sure that they have the same denominators. Okay. So we got to find out what is the LCD. LCD in this case is 6. So therefore, we're going to change both of our denominators to being 6. What do you multiply 2 by to get 6? Multiply that by 3, and whatever is to the bottom, you must also do towards the top. So 3 times 1 is 3. What do you multiply 3 by to get 6? Okay. But that's 2. So whatever is to the bottom, you must again do towards the top. So 2 times 2 is 4. So, what is 3 plus 4? That's going to be 7 over 6. 7 over 6, you have a fraction, and the fraction has integers on both the numerator and the denominator, so we classify this as a rational number. Negative 14 times negative 28 over 4. Okay. Negative 14 times negative 28 over 4. You can simplify the negative 28 over 4 down to negative 7. So this becomes negative 14 times negative 7, which is going to be a positive 98. 98 is an integer, but you can write it as a fraction as 98 over 1. And both of those are integers. So this now is also a rational number. Now, let's take a look at what we just did for both of these. Okay? What we did for the original part, for the first question, is that we had 1/2, which is a rational number, plus 2/3 is a rational number. Okay? So we got 2 rationals. And we're adding them. And our answer was a rational number as well. Look at what we did for the second part. We have negative 14, which is a rational number. Negative 28 over 4 is also a rational number. And here we multiplied those two things. And our answer was still rational. So here's the main thing I wanted you to learn from this part, is that the sum and product of 2 rational numbers is rational. Okay? Just understand that. And not only is it rational, I really should say this, is always rational. Always rational. Big stress on the always. So anytime that you add 2 rational numbers or you multiply 2 rational numbers, the answer is always going to be rational. Always, always, always. Calculate the following numerical expressions here. Classify the answers as rational or irrational. So we got 6 plus pi. 6 plus pi. So when you add those together, you type those into the calculator, add those together, your answer comes, I think it's like 9 point, yeah, 6 plus. This is going to be 9.1415, 9265, and it's going to keep kind of going on and on too as well. This answer is what we will call an irrational number. Okay, irrational. Square root of 2 times square root of 5. This is going to be the square root of 10. 10 is not a perfect square. Square root of 10 is 3.16227766016. So it keeps going on as well. So this one is what we call an irrational number too as well. Because again, you have a number where the decimal does not stop, and it doesn't have a pattern when it's not stopping either. Square root of 2 times square root of 2. This is going to be the square root of 4. Square root of 4 is 2. We can write 2 as a fraction. So this is what we would call a rational number. Here's a different color. So let's pay attention to what we just did. Okay? Let's talk about what we just did. So, let's look at this one. Square root of 100 over square root of 16. Well, here you can apply the powers of a square root to both the top and the bottom with a fraction. So we can rewrite this as the square root of 100 over the square root of 16. And if you didn't know that, now you do. Okay, anytime you get the square root of a fraction, you can split it up into the square root of the numerator over the square root of the denominator. Okay? And we'll go over that later on in the week. We'll be dealing with powers of roots. So, and it's the minus square root of 9. Square root of 100 is a perfect square, that's 10. Square root of 16, that's perfect square, that's 4. Okay. And 9 is a perfect square, that's 3. 10 over 4 can be simplified down to be 5 over 2. Minus 3. If we keep going with this one, this is now going to be 5 over 2 minus 6 over 2. Okay. Just changing 3 to 6 over 2. And remember, you can do that given what we did in the warm-up. Remember, there's many ways you can represent 3. Okay. So 5 over 2 minus 6 over 2 is going to be a negative 1 over 2. Both of these, this is in the simplest form. Both the numerator and the denominator is an integer. Hence, this is a rational number. So, let's talk about what we just did in this particular. 6 is a rational number. Pi is an irrational number, and hence our answer was irrational. Okay? So in that case, here's what I need you to understand, is that the sum of a rational number and irrational number irrational. Okay? Let's look at the next one that we did. Square root of 2 times the square root of 5. Okay? Square root of 2 is an irrational number. Square root of 5 is an irrational number, and our answer that we got was irrational. But if you look at the next one, square root of 2 is an irrational number, and the other square root of 2 is still an irrational number, but our answer was a rational one. It was 4. It was the square root of 4, which now became 2. So here's what we got to say about the product of two irrational numbers. Okay? Product of two irrational numbers. Oh, you know what? Let me go back here. Let me go back a little bit. It's not only the sum. Yeah, I messed this up. I'm sorry. My fault. The sum and the product, because we didn't have an example of that one, but I just want you guys to see that. The sum and the product of two. Oh man, let me start this over. The sum and product.
Daphne Sneed, please call Ms. Parker. Daphne Sneed, please call Ms. Parker.
Okay, let me say this one more time. The sum and product of a rational number and an irrational number is irrational. I didn't have an example for the product one, but it does follow the same rules, okay? If you have a rational number and you multiply it or you add it to an irrational number, that irrational number is going to take precedence over it, okay? So the answer is going to be irrational. Now, if we look at the other two that we did, we had the square root of 2, right, multiplied by the square root of 5. So in this case, we had an irrational number times an irrational number, and our answer was irrational. But if you look at the one right below it, we had a square root of 2 times the square root of 2. Square root of 2 is irrational, and you multiply that by another square root of 2, which is also irrational. But our answer was rational. So, the product of two irrational numbers is sometimes irrational. Not all the time. Sometimes it's irrational. And the other time it is rational. Sometimes irrational. So, this page right here is in the course workbook. Okay? Let's look at the let's practice part. It's on page 10 in the course workbook. So it says, let's practice this. Consider the following expression. 2 plus the square root of 3. So the above expression represents is it the sum or the product? Well, if it's addition, it's the sum. Okay. The above expression represents the sum of a or n rational and rational and is it rational and irrational? So what's the first term? So the first term is a 2. Is that rational or is that irrational? Well, 2 can be written as a fraction, so this is rational. And a square root of 3 is irrational. And therefore, it is equivalent to, well, we already wrote that down in your notes. So if you know it, what is the sum of a rational and an irrational? Correct, irrational. So let's try again, okay? Maria and her 6 best friends are applying to colleges. They find that Bard College accepts 1/3 of its applicants. Maria and her friends write the expression below to represent how many of them will likely be accepted. Okay? So here we have a girl and Maria, who's the girl, and her 6 best friends trying to get into a college, and they see that 1/3 of the applicants will be accepted. So they're trying to figure out, between them, how many will be accepted. Okay. So the above expression represents blank. Okay. The expression is 7 times 1/3. 7 times 1/3. So, in this case, the above expression represents a product or a sum. Here we have a product, because multiplication means product, of a blank number. 7 is a rational number, and a 1/3 is a rational number as well. And it is equivalent to a what? When you multiply a rational times a rational, you're going to get a rational back. Always, always, always true. All right, when it comes to beat the test, okay? Beat the test. You can go ahead and pause it now, try to see if you can try to answer this. Alrighty, so you should try to answer these questions, and here we go. So let A and B be non-zero rational numbers, and C be an irrational number. Consider the following expressions below, and determine whether the result will be rational or irrational. Okay? So A and B, we have those as rational or irrational. So we say that A and B are non-zero rational numbers. So here we have a rational plus a rational. Hence, the answer is going to be rational. A minus C, okay? A is rational, C is irrational. As long as you have one irrational with a rational, the answer is going to be irrational. Okay? A times B, what's a rational times a rational? Still irrational. A divided by B. A divided by B. Now here's the thing. You have a rational number that's being divided by another rational number. Well, if we work that out, right? You work it out. Just work it out over here. So if I had, let's say for instance I had 1/2 divided by 2/3. Or if we use it the other way, we have 1/2 divided by 2/3. If you already know how to divide fraction, then you already know what to do. But if not, remember the phrase, maybe you heard this in middle school, it's called keep, change, and flip. So you're going to keep the first fraction the same, change the operation of multiplication, and then flip the fraction. So this becomes 1/2 times 3/2. In that case, it becomes 3/4. 3 over 4, are both of those integers? Yes. And hence, those are integers that are being represented as fractions, so this is still a rational number. So in this case, A divided by B is a rational. Now, A times B times C. Okay? So we got A times B times C. So we got A times B. A and B are rationals. And so when you multiply those two together, they become rational. But then you taking that number and multiplying by an irrational number. Again, all you need is one irrational number when it comes to these rationals, and the whole thing is irrational. So in this case, this is irrational. I'll leave number 2 for you. You can do that on your own. And I'll see you guys tomorrow. Hopefully this video was good for you to learn.